welcome to True Projects. In this video, we are going to explain about the project which is Network Intrusion Detection with two-phased hybrid ensemble learning and automatic feature selection. Introduction. In recent years, the surge in network-connected devices has revolutionized our lives, but it has also drawn the interest of cybercriminals, leading to a surge in sophisticated attacks. Detecting these attacks, whether known or unknown, in real time, it poses a major challenge in securing network systems. Traditional security measures often fall short, requiring more advanced solutions. The project deals with the critical task of identifying and preventing cyber attacks on network-connected devices. It focuses on building a network intrusion detection system using machine learning techniques. NIDS plays a vital role in safeguarding networks application by continuously monitoring network traffic and spotting potentially malicious activities. The project innovatively combines machine learning with automatic feature selection to boost NIDS effectiveness. It automatically selects vital features, reducing noise, and employs a two-phased hybrid ensemble learning approach that outperforms existing studies in detecting a wide range of attacks. Rigorous evaluation on wired and wireless datasets proves that it has superior capabilities. Objective of the project. The primary aim of this project is to design and develop a network intrusion detection system based on machine learning techniques. This NIDS will play a crucial role in identifying and mitigating network intrusions and cyber threats. The main aim of the project is to implement an automatic feature selection process within the NIDS. This process will streamline the handling of complex network data by identifying and utilizing the most relevant features, ultimately improving the accuracy and efficiency of intrusion detection. The project's objective is to create a two-phased hybrid ensemble learning framework. This framework will incorporate multiple machine learning classifiers to enhance the NID's ability to detect a wide range of network attacks, combining the strengths of different classifiers for improved accuracy. The project aims to rigorously evaluate the proposed framework using well-established datasets like NSL-KDD in AWIDS, which represent wired and wireless network applications. This evaluation will provide empirical evidence of the framework's effectiveness and suitability for real-world scenarios. The ultimate goal of this project is to showcase the superiority of the developed NIDS solution in terms of its attack detection capabilities compared to existing studies in the field. This will demonstrate the practical value and effectiveness of the proposed systems in enhanced network security. Requirements of the project. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8GB and above, and hard disk of 25GB and above. Coming to software requirements, we need Anaconda 3 and Visual Studio Community version. To execute the project, we have designed various steps in the flow of work. The first step is importing the packages. This step involves importing the necessary Python libraries and packages that are required for the project. We have imported NumPy for numerical operations, Pandas for data manipulation, Matplotlib and Seaborn for visualizations, and scikit-learn for machine learning. Exploring the dataset. In this phase, we load and examine the datasets which are NSL-KDD and AWIDS to understand their structure, content, and characteristics. This is important for data processing and model building. Data processing. This phase involves several key steps and it is often divided into subsets to manage the complexity of data preparation. Pandas data frame. In this part, the raw dataset is loaded and converted into a structured Pandas data frame. This is crucial for data manipulation and analysis as it provides a tabular format for the data. Dropping unwanted columns. Certain columns or attributes in the dataset might not be relevant for intrusion detection or may introduce noise. Dropping these unwanted columns helps in reducing dimensionality and focusing on the most informative features. Visualization using Seaborn and Matplotlib. This step involves using Seaborn and Matplotlib to create data visualizations such as histograms, scatter plots, and bar charts for both the datasets. Visualizations helps in gaining insights into the data's distribution and relationships between features. Label encoding using label encoder. Label encoding is applied to both the datasets to convert categorical variables into numerical format, making it suitable for machine learning algorithms. The label encoder from scikit-learn can be used for this purpose. Feature selection. Automatic feature selection using select percentile with mutual information classification helps identifying the most relevant features for intrusion detection. It reduces dimensionality and focuses on the most informative features. splitting the data into X and Y for machine learning. The dataset is divided into two parts, X features and Y target labels. X contains the input features and Y contains the corresponding labels. Building the model. This phase defines and implements various machine learning models. Let's take a closer look at them. ANN, Artificial Neural Network. ANN is a deep learning technique inspired by human brain. It is used to model complex patterns in the data. In the context of intrusion detection, ANN can learn intricate relationships between network features and intrusion types. Decision trees. Decision trees are used for classification and they can represent complex decision-making process. They are interpretable and they can help in understanding which features are important for classification. Random forest. It is an ensemble technique that combines multiple decision trees. It offers robustness and improved accuracy, making it suitable for intrusion detection, where the goal is to detect a wide range of attack types. Support vector machine. SVM is effective for binary classification tasks. It separates data points into different classes using a hyperplane. In intrusion detection, SVM can be used for binary classification, that is intrusion or non-intrusion. Training and building the model. In this phase, we train machine learning models on the pre-processed dataset, which are NSL-KDD and AWIDS. Training involves feeding the model with the labeled data to learn patterns and relationships between features and variables. As an extension, we applied an ensemble method combining the predictions of multiple individual models to produce a more robust and accurate prediction, and we also built front-end using Flask framework for user testing with user authentication. Flask framework with SQLite for sign up and sign in. Here we implement a web application using the Flask framework incorporating SQLite for user authentication and management. This allows users to sign up and sign into the application. User gives input. User input their feature values through the application, which are then used for intrusion detection. The given input is pre-processed for prediction. The user's input is pre-processed to ensure it matches the format and features used by the trained machine learning models. Trained model is used for prediction. The trained machine learning models are utilized to make predictions based on the pre-processed user input. Final outcome is displayed through frontend. The results of the intrusion detection, such as whether intrusion detected or not, will be displayed through the frontend. Comparison graph. This is the horizontal bar graph which represents accuracy scores of the algorithms, and here we can see that x-axis represents accuracy scores of a particular algorithm and y-axis represents algorithm names. From all the algorithms we can understand that SVM has the less accuracy. Accuracy is the proportion of correct predictions in a classification task measuring the overall correctness of a model's predictions. This is the precision score graph, where x-axis represents precision scores of the algorithms and y-axis represents algorithm names. Precision is the ratio of true positive predictions to the total positive predictions, representing the model's ability to correctly identify relevant instances while minimizing false positives. This is the recall score comparison graph, where x-axis represents recall score of particular algorithm and y-axis represents algorithm names. Recall is also known as sensitivity or true positive rate. It is a ratio of true positives to the total actual positives, measuring a model's ability to capture all relevant instances without missing any. This is the F1 score comparison graph, where x-axis represents F1 score of each algorithm and y-axis represents algorithm names. The F1 score is the harmonic mean of precision and recall, offering a balanced measure that considers both false positives and false negatives, making it suitable for imbalanced classes. For execution of the project, first we need to open the code folder which contains source code files. This is the code folder of the project. This is the static folder. This folder consists of files related to CSS, JavaScript and Bootstrap files. This is the templates folder. This folder contains all HTML pages used throughout the project. It typically includes files like index.html, about.html, etc., which represents different pages of the website. app.py file. This py file contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file. It contains algorithm information and that will be loaded into project code during runtime. This is the IPYNB file. It is a Jupyter Notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells and making it popular choice for the data science. This is the sign-up file. This is the database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path, and now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. So here we can see that current directory is changed to the code folder's path. Here we need to type the command, which is python space app.py. This will compile app.py file, and this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. Now we need to click on enter. After running the app.py file, the Flask framework will host the application locally at the default address, which is the localhost and the port. Now we need to copy this local link provided by the framework and paste it in any browser. I prefer Google Chrome, so I'll paste it in that. So here we'll paste the link and then click on enter. This is the web page of the project, which is displayed in the browser, and this web page is built by using the Flask framework. So here first we need to click on sign up and enter all the sign up details if you are signing up newly. I've already signed up, so I'll directly click on sign in. Here we need to enter our credentials, which are the username and the password, and then click on sign in. We are signed in successfully, and we are redirected to intrusion detection page where we need to enter all these parameters. With the given parameters, attack will be detected. Now let us understand what are the parameters. This is the service. This parameter denotes the network service associated with a connection such as HTTP or FTP, help in identifying the type of network activity. Flag. It represents the status or state of a network connection, indicating conditions like connection establishment, closure or reset. Source bytes. It signifies the number of data bytes sent from the source during a network connection, measuring the data volume from the sender. Destination bytes. It represents the number of data bytes received at the destination during a network connection, measuring data volume received by the receiver. Count. This parameter indicates the number of connections to the same destination within a time interval, help in identifying scanning or probing activities. Source error rate. It calculates the percentage of connections with errors at the source, highlighting connection issues or potential attacks. Same service state. It measures the percentage of connections using the same service as previous ones, useful for detecting consistent service patterns. Different service rate. It calculates the percentage of connections using different services than previous ones, aiding in identifying service switching. Destination host service count. This feature denotes the number of services running on the destination host, providing insights into the variety of services offered. Destination host same service rate. It calculates the percentage of connections to the same destination host using the same service, revealing consistent service usage. Destination host different service rate. It calculates the percentage of connections to the same destination host using different services, help in detecting variations in service usage. Destination host source error rate. It computes the percentage of connections to same destination host encountering errors at the source, indicating the potential issues or attacks specified at the destination host. Now we will enter all these details. I have entered all the details, and now we will click on predict. It is predicted that there is no attack detected and it is normal. Now we will enter other set of parameters. I have entered other parameters, and now we will click on predict. It is predicted that there is an attack detected and the attack type is DOS or probe or R2L. In this way, if we give the parameters to the system will detect the attack. Conclusion of the project. The project successfully developed an intrusion detection system using machine learning techniques, showcasing its ability to effectively identify and mitigate network intrusions. The utilization of automatic feature selection and a two-phased hybrid ensemble learning framework, it demonstrates that improved intrusion detection capabilities, enhancing accuracy and adaptability to various attacks. Rigorous evaluation on well-referenced datasets, both wired and wireless, revealed that the proposed framework outperforms existing studies in the field, showcasing its superiority in attack detection. Out of all available models, we opted Extension Ensemble model for prediction due to its exceptional accuracy and F-score, which greatly enhances the effectiveness of the intrusion detection system. By providing a robust and accurate solution for securing network-connected devices and applications, this project contributes to the enhancing network security in the face of evolving cyber threats.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.